Hello, algebra students. Welcome back. We're in section 2.2, example 2. This should be a pretty short one. I'm going to do a brief explanation on the first one. And I think now is about probably a good time to start doing some extra credit. So thanks for listening. And let's go ahead and get started. We're now going to use a word problem to create a one-step inequality. Now, let me read this first sentence to you. The memory in Tanea's camera phone allows her to take up to 20 pictures. And I'll read the second sentence. Tanea has already taken 16 pictures. Now look at the first sentence. Are there words in there that make you think that this is probably an inequality and not an actual equation? I'll give you a second. Why don't you circle that on your paper right now? Now, if you circled to take up to, you nailed it, because that is exactly the words we're looking for that distinguish between an inequality and an equation. Equation, we're looking for words like is equal to, equals, things like that. The same as, the same amount, things like that. Those are good words for equations. But inequalities, we're looking for things like no more than, no less than, at least, at most, up to. Things like that are really indicative of an inequality. And so we want to kind of talk about this. All right, now she's already got 16 pictures. And she's already taken those 16 pictures. But her camera can take up to 20 pictures. Must be a really old camera, old-fashioned camera, because most cameras can take a lot of pictures, a lot more than that. So our goal is to write, solve, and graph an inequality to show how many more pictures Tanea could take. So how many more pictures Tanea can take. That's really what we're looking for. That would be our variable, okay? So this is how we get it started. The variable would be how many more pictures. So let's just call that X. And you can do this a couple of ways. You could say she's already taken 16. So how many more, so that would be plus an unknown amount, would give me up to. Up to means you can have 20 pictures but not more than that. So that would be less than or equal to 20. Now, some of you may have wanted to start this with your variable. You may have wanted to say, okay, how many pictures can she take if she's already got 16 pictures taken, and she can do no more than or up to 20 pictures. You could have also done it like that. They're the one and the same exact problem. You're going to get the same exact answer, and I really don't care which way you did it, okay? So we need to get X by itself. So 16 is positive and it's being added to the X. So how do you undo a positive number being added to X? You're right, you're going to subtract it. We're going to subtract it from each side. Excellent. So now we have X is less than or equal to 4. So she could do 4 pictures, 3 more pictures, 2 more pictures, 1 picture, or no pictures at all. But she can't do more than 4 because she's limited for whatever reason. Okay, so this is the inequality we're looking for, and now we're ready to graph it. We wrote it, we solved it, now we're ready to graph it. Now, warning about this particular kind of problem. I'm going to start here with 0 and go 1, 2, 3, 4. Okay, I'm going to do mine just like this. And there is a word of warning because this is really going to challenge your thinking. Because before, when we graphed our inequalities, we were drawing our empty circle, closed circle, and just drawing a line showing a trend. Well, this is a specific example. And this is what we call discrete data. Discrete data, okay? What that means is the numbers are whole number answers. So the numbers are whole number answers. So let me ask you probably a really silly question. You'll probably go, why is she asking me that? Can you take half a picture? Can you take 2.5 pictures? 3.5 pictures? Can you take 3 1/3 pictures? Can you take 2 7/8 of a picture? Now, I know that sounds silly, but the answer to all those questions, the answer is no. You can't take a part of a picture. You either take a picture or you don't. There is no in between. And because it's discrete data, because all the answers are whole numbers, then we're going to graph it differently. We're going to show our answers. She could graph or take no pictures at all. So I'm going to put a dark filled in circle on the 0. She could take 1 picture. She could take 2 pictures. She could take 3 pictures or even 4 pictures, but she can't go over that. She can't go over 4, and she certainly can't go under 0. You can't take less than 0 pictures. There's no such thing as taking -2 pictures. I don't even know how you would justify that. So we would do filled in circles, no line connecting them, because the line connecting each of these points indicates that all the answers in between 0 and 1 are part of the answer. So we're saying if I connect 0 to 1, I'm saying I could take half a picture, 1/3 of a picture, 3/5 of a picture. I'm saying all those numbers in between are possibilities, when in reality, they are not. So this would be an appropriate graph for a situation like this where you can't have partial pictures taken from a camera. You either take it or you don't. It's a whole number or it's not, okay? Because it is not going to be a decimal. You're not going to have a fraction amount of pictures there, okay? Now, I hope I explained myself well. I think you probably got the equation down pat. You know how to solve the one-step equations. The graph may have been the thing that was a little tricky, okay? So I want you guys to try this one all by yourself. I'm going to give you extra credit point. You need to do 3 things for me, okay? I want you to write, solve, and graph. Write, solve, and graph. Write an inequality statement. Solve it. It'll be a one-step inequality. Solve it for me in the space below, and then graph your answer for me. Okay? So just read carefully and do your best, and we'll go over it in class. If you have any questions, write your answers in the margin, and we will talk about it in class. Thanks for listening.